My dear students, welcome to our channel. Today we are going to discuss about the previous year, that is last 10 years CBSE board questions in part 4 in haloalkane and arene chapter. So here the first question like that, write the mechanism of the following that was asked in the year of 2014. So here one alcohol compound is given. Ethanol is given. It will be reacting with a halogen acid. So here it forms bromoethane. The product is there and water is getting formed. Okay, so now they ask the mechanism how they react. So here it's nothing but, if suppose here CH3, CH2, OH, here it contains lone pair of electrons. If it is a halogen acid, H plus should be there. H plus Br minus will be there. This lone pair will donate. This oxygen will donate the lone pair. By that way, it accepts H plus ions. Here CH3, CH2 and O. Here also H. Here accepted H will be there. And the very important thing, because of its donation, it loses electrons so that it got positive charge. Now we can see one oxygen is there. In that oxygen, two hydrogen is there. So it wants to move as water molecule. So it's a bulkier group 1. So it wants to move as water molecule. If it moves as water molecule, this bond is there. You consider this bond. Now it wants to move as water, neutral water, that is minus, it wants to move as H2O. So now what happened? So this will be a positive one. So it should get one electron. So by that way, this bond is getting break. So this will get electron which moves as water. What about this? One bond is getting break. Because of that, one negative charge is there, one positive charge is remaining. Now the positive charge is CH3, CH2 plus. Now positive charge is there. In halogen acid, we have H plus and Br minus. Okay, this H plus and Br minus. This Br minus will come and attract. Now what happened? This will be the product I am getting. That is CH3, CH2, Br. Along with I get the product as water, H2O as a product. Are you able to understand, student? This is a good mechanism. So initially the alcohol containing oxygen will donate electron. By that way it got positive charge. The water molecule leaves, the positive charge will comes to carbon. That positive charge will attract the negative charge of acid to form this compound. Now the product we are getting is proved. And second thing is, complete the following reaction in equation. So this was asked in the year of 2009 as well as 2011. In previous video also we talk about this thing. So because that is very important, that is what I am show once again. So this is the mechanism. I showed some shortcut and clues. If SOCl2 PCl5 is coming in react with alcohols, at that time we have to use this trick. So here is nothing but one Cl is there, one Cl is there, remaining SO we have to write. What will be the green product? The product is nothing but here, sorry, I'll get the product. So it's not the product. So here I am getting Cl. Along with that, one SO2 is there, one HCl is there. So here HCl is getting formed, SO plus SO2 is there. And one more thing what I'm get, so chlorocyclohexane, I'll get it. And what about the second thing? So this also asked in the year of 2009, this was asked. So in the nothing but heat is generated. If the heat is coming, the water molecule is getting eliminated. That's a general trend we have to follow. So what is the general trend? So here the water is getting eliminated, I'll get the product. So here I get the product like this. That is CH2Cl. I'll get the product like this. Are you able to understand, student? This is a very important one. And the very most important thing is, what is that? This is benzene diazonium chloride is given. If it is react with the Ki, I'll get the product like this. Here it is nothing but the Ki will move KCl. So nitrogen will come as gas. So C6H5I. So iodobenzene I'll get. Along with that I'll get nitrogen. Along with that KCl I'm getting. This is the product I was getting there. And the very important reaction, this also asked in the year of 2008. So what they asked, one alkane is given along with that bromine and CCl4. Now bromine is a non-polar molecule and it should get polarized in presence of CCl4 because Br, there is no dipole is getting created. But C carbon Cl, the polarity will be there. So now CCl4 is a non-polar molecule, but carbon Cl. So if it is interact these two, this will get polarized as Br plus. So for example, Br. So this bond is getting break. So it will come like this. What are we getting? So here it is Br plus. If it is Br minus, it will be formed as Br plus. Now the bond will be getting break. So what happened? So in one bond is getting break. So this bond is getting shifted. If it got negative charge, by that way it got positive charge in here. So here it got positive charge, here it has got negative charge. So here hydrogen is there. Now what I get? So Br minus will approach positive, the Br plus will approach negative. Okay, now I'm getting the product like this, that is HC, here one Br, so here C, here one Br, H. So I get dibromide. Here I'll get dibromide. Are you able to understand? This is a very, very important thing. And the very most important next one is, what is that? So here HBr is given, nothing but a halogen acid is given. So we have to see Markovnikov rule, whether it follows the Markovnikov rule or not. Just we have to think it about. So if it is a what kind of alkene is this? So it's an unsymmetrical alkene. We know that. So here one carbon, here one carbon. So here one hydrogen is there. Instead of that, here benzyl, that is the phenyl group is there. So it's an unsymmetrical alkene. So in that we have to follow Markovnikov rule. Markovnikov rule is what? That is a negative entity will go and approach where the lesser number of hydrogen is present in the double bond. According to that rule, here only the hydrogen which is having lesser number of hydrogen. So this Br minus will come and approach here. This H plus will go and attach here. Now I'll get the product like this. What I'm get the product? So I'll be getting the product like this. So this is what I have getting the product. So here CHBr and here CH3. This is the product I'm getting. And the fifth question is what? That is a N-butyl bromide has a higher boiling point than that of the tertiary butyl bromide. This was asked in the year of 2015. This is also a very, very important question. As you know that boiling point. So boiling point generally depends on two factors. One is if boiling point is directly proportional to molar mass. And second thing is the boiling point is inversely proportional to branching. So these two concepts should come to our mind. So boiling point is directly proportional to molar mass and boiling point is inversely proportional to branching. Now we can compare these two things. N-butyl bromide. What is a N-butyl bromide? This is a N-butyl bromide. What is a N-butyl bromide? So 1 CH3, CH2, 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 Br. This is N-butyl bromide. So and then second thing is a tertiary butyl bromide. Here also I have 4 carbon atom, but 1, 2, 3, 4. This is bromine. So here also CH3, CH3. Here also CH3. Now it's a straight chain compound. It's a branched one. So same number of carbon atom is existing, but it is a straight chain. But here it is a branching. So tertiary butyl bromide, it's a branching one. So it has less number of boiling point. Because less amount of boiling point should be there. Because molar mass is the first concept. Both are having a same molar mass. But the thing is, because here also 1, 2, 3, 4 carbon atoms. So 2, 4, 6, 9 hydrogen. Here also 1, one bromine is there. And here also 1, 2, 3, 4, 4 carbon atom, 3, 3, 3, 9 carbon atom bromine. Both are isomers. Now that is both are what is that? Here same molecular formula. So molar mass concept is fine. But the second concept we had to concentrate on the branching. So here's a straight chain. So once the boiling point is getting increases, it will be very high for straight chain compounds. For branching, once the branching will come, the boiling point will decreases, or the boiling point will decreases once the branching is getting increases. That is what this has higher boiling point. This has higher boiling point. This has a higher boiling point than that of this one. This has a low boiling point. This has low boiling point. The branched one will have low boiling point. This will have higher boiling point. And the very important next question, why does para-dichlorobenzene have higher melting point than its ortho and meta isomers? This was asked in the year of 2009 as well as 2013. In both the year they asked, why does para-dichlorobenzene? Para-dichlorobenzene, we have to write the structure. So para-dichlorobenzene, this is a para-dichlorobenzene. So 1,4th position will be occupied the chlorine. That is a dichlorobenzene they ask. That's what para. And this is a para isomer. And what about the meta and ortho isomer? Now I can write the ortho isomer. So here it is Cl and Cl. This is the ortho isomer. And if you want to write the meta isomer, this will be the name, and 1,3 position will be occupied. This will be a meta isomer. Now why this para position will have a higher boiling point, higher melting point? Why it's so? Because this is in crystal lattice. It will be because it has symmetry. It has symmetry, same plane of symmetry, so that it will be fixed in a crystal lattice in a perfect arrangement. But here we can't arrange like that. That is what this para isomer will have a higher melting point than that of ortho and meta isomers. And next one is out of methyl chloride and bromoethane, chloroethane and bromoethane. Which one has high boiling point and why? So here the boiling point, as we know that, as we see earlier, there is boiling point. First concept, it should depend on molar mass, and second one is branching. Here both the compounds are straight chain compounds. Here CH3, CH2, Cl. Another compound is CH3, CH2, Br. Okay, now so here if you consider fluorine, this is chlorine, this is bromine, this is iodine, as we know that. Okay, so here when we go down the group, the molar mass is getting increases. The molar mass is getting increases when we move down the group. According to that, the molar mass will be very high for bromo compounds. That is what this will have higher boiling point. Higher boiling point. Why it has a higher boiling point? According to molar mass concept. Because a molar mass, if a molar mass is high, the boiling point will also be very high. Are you able to understand, students? So thank you so much for watching. Please go forward to others to get benefited, and please subscribe my channel. Thank you so much for watching. Thank you once again.